Today we will discuss about generator ventilation system as per the manufacturer standard. Okay, normally this is based on ASHRAE or based on the mass transfer heat equation, but the manufacturer information will be direct, very straightforward. Okay, uh,
Okay.
I will just show you one of the manufacturer application and installation guide. Okay, for the engine room
Sure.
ventilation, so that you can
Sure.
have get some idea. Okay, normally
Mhm.
if you go to the engine room ventilation, okay, the sizing consideration is based on the cooling air and the combustion air. Okay, based on that you will calculate the ventilation airflow rate. Clear, right?
Okay, so it's based on the cooling air and the combustion air, right?
Combustion air, yes. So the cooling air basically required for the radiator, and the combustion air is
Mhm.
basically required for the combustion of the fuel. Okay,
Okay,
so
okay.
for the fuel to burn, you have to provide combustion air, right?
Yeah, yeah,
Okay,
yeah.
so both if you add it together, you will get the total required ventilation airflow rate. That's it. This is very simple
Mhm.
and straightforward. Okay,
Okay. So just to confirm again, so cooling air is basically for cooling
radiator
the
cooling, radiator.
radiator. Okay.
Okay, if I open my
Mm.
one of the diagram, okay, you can see one of the picture, right?
Yeah, I
Okay,
can
so
see
this
that.
is this is
Yes.
this is the diesel engine generator. Okay, where
Mm-hmm.
you have a discharge and also you have an intake air. Okay, so when you
Okay.
provide the intake air should be summation of the cooling air for the radiator. Okay, it should cool the
Mm-hmm.
radiator and also whatever the air required for the combustion purpose. So summation of
Okay.
both will be the total air ventilation requirement. Okay,
Mm-hmm.
and the
So,
intake, yeah.
sorry. So, this information is something that you will be receiving from the manufacturer, yes, but that will be through the electrical team, though, right? Or can we also directly contact the generator selection
No,
manufacturer?
no. Basically, the electrical team they will size the generator, right? Say for example, you have a
Yes.
different sizing rating. Okay, so based on
Okay.
that,
Okay.
they will do the sizing, and then based on
Mm-hmm.
that sizing, you have a manufacturer data sheets. Say for example, one of
Okay.
the manufacturer Cummins. Okay,
Mm-hmm.
and you can
Mm-hmm.
see the
Mm-hmm.
generator data sheet model, and you have a standby
Mm-hmm.
rating, you have a prime rating, right?
Okay. Okay.
Okay, so I will explain you
Mm.
later what is standby and what is prime and what is continuous.
Sure.
Okay, so now
Okay.
you can see the rating. You can see the rating. This is the rating they have calculated based on the
Mhm.
electrical people requirement. Okay, based on the project requirement. Say for example,
Mm.
if you require 565 kilowatt required for the particular project, so
Mhm.
this is the generator you are going to select, right?
Okay.
Okay, so based on if you come below to the sheet, okay, it is clearly
Mhm.
given what is the combustion air required. You can see the value here.
Okay.
Okay, what is the combustion air value required? And also for the radiator cooling, you can see in the below directly the cooling system airflow rate at
Mm.
12.7 mm H2O. Okay, what is the
Mhm.
airflow rate?
Mhm.
This airflow rate in meter cube per second.
Okay.
Okay, so this
Okay.
is for the cooling and this is for the combustion. So when you add it together, you will get total what is the flow rate required for the generator.
But question here. So technically, when you do, because in the ventilation, you're doing the cooling air because you said it is for the radiator cooling.
Yeah,
Understood.
radiator
But for
cooling at
combustion,
yeah.
yeah. But whereas when you're doing the combustion air is basically to extract the diesel fumes that come from the diesel pump, right? Or correct me if I'm
No,
wrong.
no, not
From
that,
burning the
not
okay.
that reason. See, if you go to the generator diagram, okay, you can see
Yes,
that there
yes.
is a intake air. Okay, the intake air when it comes,
Okay,
it is required for cooling the radiator. Okay,
okay.
and also
Mm-hmm.
you have a engine, right? When you
Yeah,
talk about fuel, when you talk about when you want to burn the fuel, right? So you
yeah,
need a
yeah.
three things. So one is the heat, okay, heat,
Mm-hmm.
and another one is the fuel, another one is the
Mm-hmm.
oxygen, right?
Yes, yes.
Okay, so now the fuel you have a diesel engine. Okay, fuel is there.
Mm-hmm.
Okay, and
Yes.
for oxygen you are going to supply the ventilation air for the oxygen. So that is the
Okay.
combustion air. That is the combustion air.
Mm-hmm.
Okay,
Mm-hmm.
so
So combustion. So
when you add it together, yeah,
yeah. So just a quick question here. So just to confirm here, combustion air is basically the air that we actually use to have the generator work. That is
yeah,
like you
generator to
mentioned.
work. Yeah, generator to
Yeah.
work. Okay, so
Basically,
after
okay.
yeah, that is for combustion air, right?
Mm,
Once the fuel is burned, okay, then after that it will become a fume. that fume will be exhausted through the exhaust pipe. You can see that exhaust pipe, right?
Okay. Okay.
Okay,
Understood.
clear, right?
Yes,
So this
yes.
is the way the generator ventilation system works. Okay, and we will discuss more further. Okay,
Yeah.
now if you go to this particular sheet, you can see that engine room ventilation, what is the sizing to be considered based on the cooling air and based on the combustion air. You are able to calculate the ventilation flow required.
Ventilation
Okay,
requirement.
so if you
Yes.
talk about the manufacturer data, how they arrive this particular value, okay, this is based on the heat transfer equation. Okay, if you go down, if you go down below, you can see the heat equation, right? Q equal to mcp delta T.
Okay.
Okay, the same equation, the ventilation air equal to heat radiation, that is engine generator. Okay, D equal density of the air, C is the specific heat of air, and the delta T is the permissible temperature room rise in engine room. Okay, so what is the chance for, say for example, your generator room in the June generator room, you can say for example 48 degrees Celsius. Okay, okay, and it can go up to, assume that it can go up to for like 55 degrees Celsius. Assume like that. Okay, so what is the difference? That is the delta T. Okay, that is the yeah. So you can see that there is a permissible rise in engine room temperature of 11 degrees Celsius.
Okay, so but this permissible rise in engine room temperature that they say that is 11 degrees, that is only with respect to this example though. So based on your experience working in Dubai, so for example, our outdoor temperatures is 46. So do you take that 46 as your worst case scenario, or do you take the temperature
46 as a worst case scenario. Okay, see,
Okay.
when you actually, if you talk about worst case scenario, it will come as a 48 only, because if you see that delta T, okay, the delta T is divided by delta T, right? The more the value, you will get lesser flow rate, right?
Okay.
Okay, so that is the one. So if you take 48 degrees Celsius as a temperature, then you will get more airflow rate,
More
because
airflow rate.
the temperature is very higher, right?
Temperature is very high. Yes.
So based on that equation only, plus combustion air.
Okay.
The combustion air, what is the amount of air required to burn the fuel? Okay, so this is the equation.
Okay, this combustion air into, okay, so yeah, so but okay, but this is this in the equation right now you're showing the ventilation requirement is Q is equal to mcp delta T plus the combustion air. So that combustion air is what we take from the selection.
Yeah,
In
from the
which they have
selection
mentioned
sheet.
that.
Yeah,
Yes.
from the selection sheet.
In that,
And even
sorry.
Yeah, even if you see the combustion air direct value from the catalog, and also you can take the direct value for the cooling system as well. This is the direct value they calculated based on whatever the formula used. Okay, based on the same formula they have calculated this value as well.
Okay. So that means the ventilation, that the formula that we just now saw is basically that's the value that we come across, correct? The 14.5.
Yeah, 14.5. Yes.
Okay. Understood.
Okay,
Understood.
so normally they don't do the calculation. Okay, what they do, they do based on this particular calculation, this particular selection sheet. They get the value directly here. Okay. Okay. So this is one of the example that also I'm showing. Okay. So you can see the engine dissipation and generator dissipation, right? Okay. The CFM is calculated based on that equation. So this particular sheet I'm just using how they have calculated the flow rate. Clear, right? Okay. Then you can see here, as per air flow rate, as per the below catalog per generator, radiator air cooling air and the combustion cooling air. So both will be summation of total volume flow rate required for that particular generator ventilation.
Okay. Understood.
You got idea, right?
Yeah, I've got the idea. But now my question is, can you go back to that the engine room ventilation sheet you just not the standard, not the data sheet? Yeah. So, for example, what is that into F that they have considered?
This is the factor. This is the factor.
Okay.
Okay, the factor, I will tell you why the factor is required. Okay, if you go further down, okay, see, normally when you design the generator ventilation, okay, you have to pump the air in front of the radiator for the better cooling. Okay, and you have to take out the exhaust, something like this. So if you talk about my diagram, you can see that there is an intake in front of the radiator, and you can see that the discharge. Okay.
Mhm.
So this factor, if I say, it will be one factor. If I say this
Mhm.
factor, it will be one factor, right?
Yeah. So based on the concept that the intake is as close to the radiator,
As
correct?
close to the radiator. Yes.
Yes. Okay.
Okay. Then if you go further down, see that there is another concept where you can see that very bottom, like there is a service walk and they are supplying from the bottom. So this is one of the example where the same factor also can be taken as a one factor.
Hmm.
Okay. When you have this
So,
case, when you cannot pump the air in front of the radiator, when you have a higher rate, then you have to multiply by 1.5, right? That means your flow rate will be increased.
okay. So, but that means when you're designing, you will also have to design the ductwork that is
Yeah,
okay.
yeah. In such a way that
Mm.
you're pumping the air in front of the radiator, directly
Directly in
into the
front
radiator.
of the.
Yes. If you keep it away, then you have to multiply by 1.5 times factor. Okay. Then
Mm,
still you
mm,
have worst case. See, if you pump on the top of the generator,
mm.
what is the flow rate? Can you see here? What is the factor?
Yes. 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 Yes.
Okay. And when you
Okay.
see here intake and exhaust on the top side, this is incorrect
Mm.
airflow rate. That means your engine will be get hotter.
Hotter because you're not actually allowing the air to reach the radiator. Instead,
Reach the
it is being
radiator. Yes,
yeah,
yes,
because your exhaust fan is also working at the same time as your intake fan, and then your air is ideally being pushed directly through the exhaust fan,
yes,
and you're
yes,
not letting
yes.
the air reach the radiator. So
Yeah,
ideally
correct.
speaking, all of our like ventilation requirements that we are following, we should always ensure that. Yeah, ensure that the ductwork, whatever we are sizing, should either be closer to the radiator or under the entire generator itself. The
Yeah,
ductwork needs to be extended till there. Okay.
yes, yes. Normally, if you see, you will not get a chance to run under below, but normally you will get a
Yeah,
chance
it
to
is
run in front of the radiator.
in front of, yes, yes. But then generally these generator rooms are something that we always say naturally ventilated, right? There will be a scenario where you would have open doors, or not open
Okay,
doors, like
okay.
doors with a different mesh. Yeah, yeah.
Yeah, that I will explain you
That's a
in the
different
next.
concept though, right? But
Yeah,
this is in the situation if you have a
no, this is
closed
the
room that.
yeah. What we calculated is basically we calculated based on the what is the ventilation airflow required, right? Then now I
Hmm,
will tell
hmm,
you about the scenario. Okay, there are
hmm.
multiple
Okay.
scenarios. Okay, now
Okay, sorry.
assume that you don't have any rooms. Okay, you kept
Yes.
the
Yeah.
generator outside, right?
Okay. Yeah.
Okay, so you can able to get the air from naturally from outside, right?
Yes. Yes.
Because there is no
Yes.
enclosure. Okay, this is the case
No.
one. So you can get
Hmm.
the airflow rate which is required for the radiator cooling and whatever the airflow
Hmm.
rate is required for the combustion purpose. Because in the
Combustion.
generator there is an inbuilt fan, radiator fan will be there.
Okay.
Okay, you are not going with external fan, something like this. Okay, you are going. There
Hmm.
is an
Hmm.
inbuilt generator fan. So whatever the inbuilt generator fan can uh,
Suck
whatever
the
the
air from
yeah
the
suck air
environment.
from environmental. Okay, whatever required for
Mm,
combustion and also for the radiator cooling. Clear, right?
mm, mm, mm,
Okay,
mm.
now I
So
will
is that
yeah.
yeah, sorry. So is that fan that you said, the fan that is the radiator fan itself? Just for my understanding, the generator will have the fan even irrespective of the situation. The radiator fan that you were saying, it is there in all the scenarios, right?
All the
Even if the
scenarios,
room
yes.
is all
Yeah,
the
all the
okay.
scenario it will be there. Okay.
Mm,
Okay. But only one thing you note down that the particular the generator radiator fan can have a
yeah.
maximum of 12.7 mm H2O, which is nothing but 127 Pascal.
That is the maximum pressure that the
Pressure
fan can handle. Pressure drop
fan
or
can handle.
pressure.
Yeah, pressure drop can
Mm,
handle. Okay.
mm,
Okay.
mm,
Now I will tell you case two scenario. Okay. Now case two scenario, what you have, say for example, you have a room enclosure, right? You have a room
yeah.
enclosure here, but there is a no much concern about the noise criteria. Okay.
Okay.
Okay. Now what you can do, you can just directly connect the fan from the radiator inlet to the outlet, right? Can you see here?
Mm,
I can connect like
yeah.
this, right? Okay, because I'm not
Mm,
going with any of the sound alternator. Okay, what I'm
okay.
going, what accessories I have? Simply I have an intake louver, then I have a
Mm-hmm.
discharge louver, then I have a duct connection
Mm-hmm.
pieces. Because this duct connection piece is required, otherwise, what will happen if I discharge? That particular air will be inside the room itself, right?
Mm.
Okay, so to discharge it out from the room, I have to connect with a small duct piece.
Okay. Okay.
Okay, so then only I can
Yeah.
discharge that particular air, whatever the hot air, because radiator
Yes,
cooling. Whatever the
yes.
incoming is the radiator cooling, and then after that it
Yes.
will become a hot air. That hot air will be discharged outside the room. Okay, so that is why I had to provide a one duct connection. Okay. Now what will be the pressure drop? Assume that my louver will be 25 pascal and discharge louver will be 25 pascal and the duct connection
Yes.
approximate assume that 10 pascal. So if I add
Depending,
together,
you're gonna,
if I
yeah.
add together approximate 62.5 or 65 pascal, which I am less than the radiator fan, right?
Okay,
Pressure
okay,
drop.
okay. Yes, 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 yes.
So that means
Okay.
I don't require any of the external fans. Clear, right? The
Yeah,
radiator
yeah,
fan
understood.
can able to take care of whatever the ventilation
Air
requirements.
that it is trying to throw in and throw out, basically.
Yes, basically, yes. Okay.
Understood, understood.
Okay.
Okay.
Now I will go to the another case 3 scenario. Okay. Now assume that I have installed my generator which is very close to my office buildings or which is very close to my some entity. Okay. So what I have to do, I have a much concern about noise criteria. Okay. Okay. Then what you will do, you will provide this particular room size and you will provide the noise detail of the generator to the alternator sound alternator supplier. Okay.
Yeah.
Okay. Then he will start doing the treatment for this particular room. Okay. What he will do, he will size the alternator to reduce the noise level. He will size the alternator. Depends upon the your room size, right?
Yes.
So there will be intake at sound alternator, there will be discharge sound alternator because the noise can transfer in both direction.
Yes.
To avoid that, I have to provide one alternator here. I have to provide an alternator here. Okay. So this alternator, I have to size it properly. Make sure that I am not exceeding 12.5, 127 pascal. Assume that my louver is approximate 20 pascal. My alternator is 25 pascal. And this alternator 25 pascal and this is 20 pascal. And the duct connection will be 10 pascal. Assume like that. Okay. So 25, 25, 50, 50. This 20, 20 will be 40 pascal. So 50 plus 20, 40, 90 pascal. Then I have a duct connection pitch which is 100. So still I am within the limit 100 pascal, right?
Yeah, yeah.
So then still I don't require any of the external fans.
Yeah, but this is where my doubt starts, Pranay. For example, you have a supply side where you basically have, an attenuator, your duct piece, and everything. So that means, say, for example, can you tell me how much you've considered for the attenuator as a fact, like rule of thumb, 40 or no?
No, just assumption 25 pascal.
Assumption, right? Okay, let's go for the assumption, say for that matter. For the louver, you have considered 25. Ductwork, we consider like, 10 or 20 pascals. So 25 plus 10, that's 35. 35 plus the attenuator may be another 30 pascals. Then that means 95 pascals just on the supply side. Yeah.
Okay.
Then you have on the other side a similar, say we have a similar thing on the other side, 95 pascal together. Now my question is this 95, 90, 95, 95, if you all multiply it, it could be more than your radiator fan, right?
Yeah, if it is more than radiator fan, then I have to go with the external fan.
Okay. This is where I wanted to come.
This is the where you require external fan. Okay. So whatever the accessories, whenever you design very initial time, whatever the accessories, you design it with a very low pressure drop.
Okay.
But sometimes
so you will have to communicate this with your manufacturers.
With
you have to give them your radiator fan pascal requirement as well, so that they keep this in mind as well. Understood.
Yes. Okay. Now whatever you're calculating your accessories pressure drop, which should be less than 127 pascal. Okay. But sometimes you cannot match it. Okay, because of the room sizes. Okay. So because of the room sizes, you have to go with the small alternator, but that alternator pressure drop will be higher because of the airflow rate.
Airflow rate.
Okay. So when in that case, you have to go with the external pressure, external fan. So external fan required, you require static pressure and also you require airflow rate. So this particular airflow rate will be the same as the intake airflow rate.
Yes.
Okay. And the pressure drop will be whatever you require to pump inside the generator room. So this particular sound alternator, this particular louver, okay. So that should be calculated, that should be added to the generator external fan pressure drop. So that you are pumping the air into the room. Okay. Then say for example you are discharging, you require only 95 pascal as per you, right? So 95 pascal means within the 127 pascal. So what it can do, it can suck the air and it can discharge.
Understood.
Okay. Assume that this 95 pascal instead of 95 pascal, assume that it is 150 pascal because of my long duct routing.
Yeah.
Then you will provide with
an extra fan.
extra fan for the discharge as well.
Discharge as well. Hmm. Hmm. But
Clear,
that
right?
means in this case here, Pani, there would be scenarios where you would have like a scenario where you might require both a supply fan and exhaust fan, and because of the because of the pressure drop requirements, and so
Yeah.
how has it been? How have you been able to do this? The supply and discharge louvers. Sometimes there are architects who would be like, why do you need the 6 meter distance?
No, no,
Is
no.
there like
No,
this is
not
where
that
I
case.
want to.
Yeah, see, for example,
Ah,
I have handled one of the project, okay, where my
yeah.
project is somewhere, this is my underground floor, okay, where I'm going to
Okay.
keep my generator in the basement,
Okay.
okay. So there where I
Hmm.
need my intake and exhaust should be far away, right?
Yes, very far away.
So
Yes.
assume that I have an intake here somewhere here. I have to run my
Mm-hmm.
ducting all the way from here to here, right, for the
Mm-hmm.
intake.
Mm-hmm. Mm-hmm.
And for the
Yes.
discharge, assume that I have a discharge louver here and I have to run my
Mm-hmm.
ducting all the way from here to here. So when I calculate
Understood.
my this pressure drop, which is exceeding more than
Mm.
126 Pascal, and when I
Yeah.
calculate this pressure drop, which is exceeding more than 126 Pascal. So in this case, I
Mm-hmm.
require intake fan to take care of this pressure drop and discharge fan to take care of this pressure drop.
Okay. Okay.
So this is the
So
case.
yeah,
I go with
yeah.
both external
Fans,
fans
fans
for
for both the
for
scenarios.
the intake and the discharge.
Yes, but now coming up to this here, so both the fans that you're adding, you would have. So you said this is the basement. Let's go with the example that you have said. In the basement itself, will you be adding these fans within the generator room in itself, or will you be having these fans in the high level of that particular basement? Say, like, or is it still depending on the size of the fan, or is it like what are the metrics that you take that into consideration?
Okay, see there are one parameter you have to consider when you have a noise criteria. Okay, say for
Mm,
example, I'm going
mm,
to keep the fan in the roof, right?
mm,
So then I can keep it on the roof itself.
Okay,
Okay,
you mean in
this
the high
particular
level
project,
itself, you will just
yeah,
roof
this
the
particular
ductwork
project,
with roof. Okay.
yeah, in the high level, I can keep my fan at the roof level.
Mm, mm, mm,
Okay, let me tell you
mm,
about this particular this particular project. Okay, what it
Yes.
happened. Okay, so this
Okay. Okay.
particular project, my fan is my generator is in the in the basement. Okay,
Yes.
and this is my
Yes.
intake. This is my intake. Okay,
Okay. Yeah.
remember if you go to Business Bay area like Bollywood, the downtown
Mhm.
area. Okay,
Yeah.
so what is happening?
Mhm.
This particular area you can able to walk, right? Remember
Yeah.
when you go to the Bollywood area.
Yes.
Okay, you
Yes.
can able to walk out external. Okay, so
Mm.
this particular louver. Okay, say for example, this is
Yeah.
my louver, right? Like
Mhm.
of course with the enclosure kind of things, aesthetic enclosure kind of thing with the louvers.
Yes.
Okay,
Yes.
everything. So when the people walk somewhere here, what is happening? They can able to listen the fan noise.
Ah. Okay.
Okay, so
Mm.
that particular case, what we did, we have shift that fan from external to internal. We kept it the fan internal here
Within the generator room itself.
within the
Okay.
generator room itself. So what is happening
Mm.
when the fan runs? It can take the air from this area to here,
Mm. You'll
and it
only
will pump
have
the
to
air into
divert.
the, yeah.
Yes, you will. Okay, so in this case here, you will have to change the factor F that you consider in your calculation, because you won't be able to directly throw it like as you've shown in this example. Instead, you will have to have a higher F factor, which
Yeah,
means
yeah,
higher. So that means the flow rates will change accordingly.
will change accordingly. Yes, yes. Depends
Yes.
upon the
Okay.
factor. How you are going to mount the
Yes.
fan.
Yes, yes, yes. Okay, okay. So this is one thing I wanted to take note. So F factor depends on the positioning of the. Okay, depends on the flow air. Okay, I was just trying to understand this concept. Flow of air
Yeah.
to, but this F factor is only the air that is the total air that you're throwing to the. Sorry, this is basically the cooling air that you're talking about, right?
Yeah,
Cooling air
cooling
for the
air. Yeah,
radiator.
cooling air for radiator,
Yes, yes. Okay.
not for the combustion. Combustion, whatever is required for the air, you are going to pump into the room itself, right?
Yes, yes.
If you pump anywhere, it can take the air from for the fuel
Mm,
purpose.
mm,
Okay,
mm,
but the
mm,
very main
mm.
concern about is the radiator cooling. So radiator cooling
Right.
should be placed in front of the radiator itself. It's same like car,
Mm.
right?
Yes, yes, yes. Yeah, it's in the front so that you have the air pass as you move, the air passes into the radiator and then does its cooling. Understand? Understand.
Okay.
Okay.
So
And
so this is
then,
the
yeah.
yeah. So this is the way to calculate the generator ventilation fan airflow requirement.
Hmm. Hmm.